Take a deep, slow breath in. Feel the air as it enters your lungs, cool and crisp, and then release it, letting out the weight of the day with a long, steady sigh. As you lie here, tucked into the safety of your blankets, notice the points where your body meets the surface beneath you. Your heels, the backs of your legs, your lower back, and your shoulders. Feel the gentle pull of gravity, that ancient force that has held you to this earth since the moment you were born. It is a constant, comforting embrace. Close your eyes, if you haven't already. Imagine that the room around you is beginning to soften. The walls are fading into a gentle, charcoal mist. The ceiling is opening up to the night sky, but you remain perfectly warm, perfectly safe. Now, I want you to bring your attention to your toes. Wiggle them slightly, then let them fall still. Imagine a wave of relaxation, like cool, liquid silver washing over your feet. It moves up to your ankles, softening the muscles. It flows over your calves and knees, dissolving any lingering tension. Your thighs grow heavy, sinking deeper into the bed. Feel that silver wave move through your hips, your lower back, and up your spine, vertebrae by vertebrae. Your chest rises and falls with the rhythm of the tide. Your shoulders, which carry so much of the world's weight, now drop away from your ears, melting into the mattress. The relaxation flows down your arms, through your elbows, and out of your fingertips. Finally, let your jaw unclacken. Let your tongue rest away from the roof of your mouth. Your eyelids are heavy. You are ready to leave the ground behind. Imagine now that the gravity holding you is beginning to thin. You aren't falling. You are simply becoming lighter. You are rising slowly, drifting through the roof of your house, past the treetops, and through the cooling layers of the atmosphere. Below you, the lights of the city look like a handful of spilled diamonds on black velvet. The air becomes thinner, quieter, until the hum of the world fades into a perfect, velvety silence. You are now in the realm of the great quiet. You are floating in the low Earth orbit, approximately 340 miles above the surface of our planet. This is the path taken by the Hubble Space Telescope, which was launched on the 24th of April 1990 aboard the Space Shuttle Discovery. Here, the atmosphere no longer blurs the light of the stars. In this vacuum, the stars do not twinkle. They shine with a steady, unblinking brilliance, like steady beacons in the dark. As you float here, you feel the gentle, rhythmic vibration of a great instrument nearby. It is the Hubble itself, a school bus-sized sentinel of silver and gold foil. It is moving fast, traveling at about 17,000 miles per hour to maintain its orbit. But to you, it feels like it is standing still, locked in a slow, graceful dance with the curvature of the Earth. Consider the texture of this machine, the cold, polished glass of its primary mirror, 2.4 meters across, waiting to catch the faintest whispers of light from the edge of time. We are here to revisit a specific moment in the history of our species' curiosity. In December of 1995, for 10 consecutive days between December 18th and December 28th, the directors of this telescope did something that many thought was a waste of precious resources. They pointed the telescope at a patch of sky that appeared to be completely empty. Imagine looking up at the constellation Ursa Major, the Great Bear. Near the handle of the Big Dipper, there is a tiny, unremarkable keyhole of darkness. To the naked eye, and even to most ground-based telescopes, there was nothing there. No stars, no nebulae, just the void. To understand how small this patch of sky is, Imagine holding a single grain of salt at arm's length against the black of night. That tiny, infinitesimal speck is the size of the Hubble Deep Field. It represents only 1/24 millionth of the whole sky. It is a sliver of the universe so small it seems impossible that it could hold anything at all. But as you float here, weightless and calm, you watch as the telescope's wide field and planetary camera 2 begins its work. It doesn't just take one picture. It stares. For 10 days, it keeps its electronic eye fixed on that single grain of salt. It performs 342 separate exposures, layering them one on top of the other, gathering photons of light that have been traveling through the vacuum of space for billions of years. You can almost feel the patience of the machine. In the silence of the vacuum, there is no sound of a shutter clicking, only the internal hum of electronics and the slow rotation of gyroscopes. The telescope is drinking in the darkness, waiting for the light to arrive. Think about the journey that light has taken. It began its voyage long before the Earth existed, long before the sun was even a cloud of dust. This light has traveled across the expanding reaches of the cosmos, moving at 186,000 miles per second, never stopping, never tiring, until it finally reaches this silver cylinder floating above our blue planet. As we drift closer to the result of this experiment, the darkness begins to change. The empty patch of sky is no longer black. As the 342 images are processed in your mind's eye, the void begins to bloom. It is like watching a garden grow in fast motion, but instead of flowers, we are seeing the birth of galaxies. In that tiny, microscopic sliver of space, that grain of sand at arm's length, Hubble found approximately 3,000 galaxies. Each one of those dots, those smudges of light, is a galaxy like our own Milky Way, containing hundreds of billions of stars. The colors begin to emerge now. You see vibrant oranges, pale creams, and deep, bruised blues. These are not the colors of nearby stars, but the colors of entire island universes. Some are elegant spirals, their arms winding like glowing silk around a central core. Others are elliptical, smooth and glowing like polished river stones. And some are irregular, tangled webs of gas and starbirth, distorted by the gravity of their neighbors. Consider the scale of what you are observing. In this one image, you are looking at nearly 3,000 civilizations worth of stars. If each of those 3,000 galaxies has 100 billion stars, you are looking at 300 trillion suns in a space no larger than a grain of salt. The temperature of your thoughts cools as you realize the sheer depth of this field. You aren't just looking across space, you are looking back through time. Because light takes time to travel, you are seeing these galaxies as they were in the distant past. Some of the smallest, reddest specks in the deep field are seen as they were over 12 billion years ago. You are looking at the universe when it was in its infancy, only a few billion years after the Big Bang itself. As you arrive at the center of this observation, you feel a profound sense of peace. The comforting void is not empty at all. It is teeming with life, with light, and with the slow, rhythmic heartbeat of physics. The universe is much more crowded, much more beautiful, and much more ancient than we ever dared to imagine. You are floating now, right in front of the deep field. It hangs before you like a tapestry of jewels. You can feel the faint, metaphorical warmth of those trillions of suns. Even though you are in the cold vacuum, there is a sense of radiance here. The light is soft, filtered through the lens of history. Notice the stillness. Out here, there is no wind to disturb the galaxies. There is no friction to slow them down. They move in a silent, cosmic choreography, guided by the invisible hand of gravity. You see a pair of galaxies in the distance, their edges beginning to touch, a slow-motion collision that will take hundreds of millions of years to complete. It is a dance of unimaginable scale, happening in a silence so deep it feels like a physical presence. Your breathing is slow and steady. You are weightless, suspended in the dark, surrounded by 3,000 galaxies. You feel the connection between the atoms in your own body and the atoms being forged in the hearts of those distant stars. You are not a stranger here. You are a part of this clockwork. Take a moment to simply be present with the scale of this discovery. In 1995, we looked at nothing, and we found everything. We found that no matter where we point our eyes in the dark, the universe is waiting to be seen. It is full of light, reaching out across the eons to find us. As you drift further into this observation, you feel a sense of awe that is quiet and sedative. It doesn't demand anything of you. It only asks that you watch and breathe and exist. The light of 12 billion years ago is washing over you now, a gentle, ancient glow. You are safe in the vastness. You are home in the stars. The telescope continues its silent vigil, and you continue to float alongside it, your mind expanding to match the dimensions of the deep field. Every breath you take is synchronized with the slow rotation of the heavens. The deep, dark indigo of the background space is a velvet pillow for your thoughts. We have arrived at the destination. We are standing, or rather, floating at the edge of the known. The grain of salt has become a cathedral of light, and as you look into the depths of these 3,000 galaxies, you feel your eyelids growing even heavier. The complexity of the world below is gone, replaced by the simple, beautiful mathematics of the stars. You are calm. You are centered. You are ready to look closer. In the next part of our journey, we will drift into the individual structures of these galaxies, feeling the pull of their gravity and the warmth of their glowing cores. But for now, just drift. Float in the knowledge that the darkness is never truly dark. It is only waiting for us to look long enough to see the light. Rest here, in the silence of the Hubble Deep Field. Let the colors, the ambers, the magentas, and the soft whites swirl behind your closed eyes. You are a part of the 300 trillion suns. You are a part of the 12 billion years. You are exactly where you are meant to be. Breathe in the starlight. Breathe out the tension. You are weightless. You are at peace. You are hovering now in the quiet stillness that exists between the stars, suspended in the boundless theater of the cosmos. The image of the Hubble Deep Field is no longer a photograph on a screen. It has become your entire reality. As you remain in this state of weightless observation, notice how the silence here isn't empty. It is a thick, velvet presence that cushions your thoughts, allowing the frantic pace of terrestrial life to dissolve into the ancient rhythms of physics. To truly understand the light you are seeing, we must look back to a pivotal moment in human history. In late 1995, the scientific community was gripped by a quiet tension. Robert Williams, the director of the Space Telescope Science Institute at the time, decided to exercise a unique power known as director's discretionary time. He chose to devote a significant portion of the telescope's scheduled 10 precious days to staring at a void. At the time, this was an unprecedented gamble. Many researchers believed the telescope would see nothing but the grainy noise of its own sensors. They feared it would be a waste of one of humanity's most expensive instruments. Picture the scene in the control rooms back on Earth. While the world went about its holiday celebrations in December of 1995, the Hubble was 340 miles above the surface, locked in a rigid, unwavering gaze. It was orbiting the Earth every 96 minutes, a rhythmic, mechanical pulse that mirrors the steady beating of a heart. Despite this high-speed travel, the telescope remained perfectly still relative to its target. This was made possible because the chosen patch of sky in the constellation Ursa Major lies within Hubble's Continuous Viewing Zone, or CVZ. This is a specific region near the celestial poles where the telescope can look at a target without the Earth ever rising or setting to block the view. Because of this CVZ, the Hubble could stare at that single spot, uninterrupted, for orbit after orbit. As you float here, imagine you can see the 4 distinct filters the telescope used to construct this view. Hubble didn't just take a color snapshot. It meticulously gathered light through 4 specific wavelengths: 300 nanometers for ultraviolet light, 450 nanometers for blue, 606 nanometers for red, and 814 nanometers for the near-infrared. At this moment, visualize the 300 nanometer light as a faint, ethereal violet glow. This is the light of the hottest, youngest stars, some of them tens of times more massive than our Sun, burning through their fuel with a fierce, short-lived intensity. Now, feel the warmth of the 814 nanometer infrared light. This light is invisible to human eyes, but here, in your mind's eye, it appears as a deep, soothing crimson. It reveals the older, cooler stars and the galaxies that are shrouded in blankets of cosmic dust. What we are observing is a core sample of the universe. Just as a geologist drills into the Earth to see the layers of history trapped in the rock, the Hubble Deep Field drills through the layers of time. Throughout history, humans looked at the dark patches of the night sky and saw only a ceiling, a limit to our vision. In 1995, that limit was shattered. We realized that the nothing was actually a window into the everything. Consider the phenomenon known as redshift, or Z, in the language of astronomers. Because the universe is expanding, the galaxies are moving away from us, and as they do, the light they emit is stretched out. Think of a rubber band being pulled thin. As the light waves stretch, they move toward the red end of the spectrum. Many of the galaxies you see before you have a redshift of Z equals 4 or even higher. This means that by the time their light reached the Hubble's mirror, it had been traveling for over 12 billion years. At this very moment, you are looking at the universe as it existed when it was less than 10% of its current age. What's happening now is a slow realization of the scale of growth. In the foreground of this field, the galaxies look like the ones we are familiar with, stately spirals with glowing arms. But as your gaze moves deeper into those faint, reddened specks, the shapes change. Scientists discovered from this image that galaxies in the early universe were much smaller and more chaotic. They weren't the grand islands of stars we see today. They were fragments clumping together under the slow, patient pull of gravity. It was through this image that we learned star formation peaked about 10 billion years ago. Since then, the universe has been slowly, gracefully settling into a quieter middle age. Find yourself drifting closer to one of these ancient, irregular galaxies. It doesn't have a defined shape. It looks like a soft, glowing cloud of turquoise and gold. Within it, billions of stars are being born from the collapse of cold hydrogen gas. This is the rhythmic life cycle of the cosmos. Gravity pulls gas together until it ignites into a star. The star shines for millions or billions of years, and then, in its passing, it scatters heavier elements back into the void to become the seeds for new worlds. You can almost feel the gentle, subsonic thrum of this process, a cosmic heartbeat that spans eons. Notice how the colors in the deep field are not just beautiful. They are a map of temperature and age. The pale, cream-colored galaxies are often elliptical, filled with ancient stars that have been shining steadily for 10 billion years. They are the elders of the cosmos. The vibrant blue smudges are the nurseries, filled with the short-lived stars that live and die in a mere 100 million years. Every color you see is a different chapter in the biography of the universe. In 1998, a few years after this first image was captured, astronomers pointed the telescope at a patch of sky in the southern hemisphere, in the constellation Tucana. This became the Hubble Deep Field South. They did this to test a fundamental rule of the universe, the cosmological principle. This principle suggests that on a large enough scale, the universe looks the same in every direction. And indeed, the Deep Field South revealed another 3,000 galaxies, matching the first image almost perfectly. This confirms that no matter where you are, no matter which way you look, you are surrounded by a sea of light. Permit your mind to settle on the physical dimensions of this view. The entire Hubble Deep Field covers only 2.5 arc-minutes of the sky. To put that in perspective, if you looked at the full moon, you would need about 150 deep fields to cover the moon's diameter. It is a tiny, microscopic keyhole. Yet, through this keyhole, we see that the universe is not a cold, empty place. It is a garden that has been growing for 13.8 billion years. As you observe these 3,000 galaxies, imagine the raw data being beamed down to Earth. In 1995, the 40 gigabytes of data generated by this image was a massive amount of information. It took weeks of processing to align the 342 separate exposures and remove the noise of cosmic rays, tiny, high-energy particles that strike the telescope's sensors like microscopic sparks. The final image is a masterpiece of human patience and machine precision. It is a testament to what happens when we choose to look into the dark with an open mind. Deep within the fabric of this image, there is a sense of profound order. The galaxies are not scattered at random. They are part of a vast, invisible web of dark matter, the scaffolding of the universe. You can feel the weight of this structure, a gentle, gravitational tether that keeps everything in its place. Even as the universe expands, these galaxies remain bound to the logic of physics, rotating slowly, drifting through the dark like embers from a distant fire. At this very moment, your breathing has slowed to match the pace of these celestial movements. The 17,000-mile-per-hour orbit of the telescope feels like a slow, rhythmic sway. The billions of years represented in this single field of view make the stresses of your day seem like the briefest of flickers. You are observing the big picture in its most literal sense. The light from those Z=4 galaxies is hitting your consciousness now, warm and ancient. This light has survived the expansion of space itself. It has traveled across the void, past supernovas and black holes, through the dust clouds of our own Milky Way, just to be seen by you. It is a gift from the beginning of time. Allow your awareness to expand until you are no longer just a spectator, but a part of this field. You are composed of the same elements, the carbon, the nitrogen, the oxygen that were forged in the stars of these very galaxies billions of years ago. As you float here, you are simply returning to your origin. The silence of the Hubble Deep Field is the silence of a home you have always known, but are only now rediscovering. Everything is moving exactly as it should. The stars are burning, the galaxies are rotating, and the light is traveling. In this boundless theater, there is nothing for you to do but watch and be still. The clockwork of the universe is reliable, steady, and infinitely patient. You are safe within its gears. You are a part of the slow, magnificent dance of the light. Rest in this history. Rest in the knowledge that even in the darkest, most empty parts of your life, there is an unimaginable depth of light waiting to be discovered. All it requires is the patience to look and the willingness to wait for the photons to arrive. As we continue our journey, we will sink deeper into the specifics of these light years. But for now, just drift in the historical glow of the deep field. The void is not a vacuum. It is a reservoir of stories, and you are here to listen to them all. As we linger in this weightless suspension, floating before the glowing tapestry of the Hubble Deep Field, imagine your consciousness is as sensitive as the silicon wafers of the telescope's heart. We are no longer observing from a distance. We are merging with the mechanics of the observation itself. At this very moment, your body feels as light as a single photon, those fundamental particles of light that have traveled billions of light years just to touch the senses of our imagination. To help you grasp the incredible precision of what we are witnessing, consider the angular resolution of the Hubble Space Telescope. It is capable of a resolution of 0.05 arcseconds. If you were standing in New York City, this would be the equivalent of being able to see a single firefly in Tokyo, or reading the fine print on a newspaper from over a mile away. Grant your mind permission to settle into that level of focus. There is no blur here, no static, only the sharp, crystalline clarity of ancient light hitting a digital eye. Picture the instrument that captured this view, the Wide Field and Planetary Camera 2, often referred to by its scientific name, WFPC-2. This camera was not a single flat sensor. It was composed of 4 distinct silicon CCD chips arranged in an L shape. 3 of these were wide-field chips, while the 4th was a high-resolution planetary camera. This is why the iconic image of the Hubble Deep Field has a strange, staircase-like cutout in one corner. It's a mechanical thumbprint, a reminder of the human-made hands that crafted this lens to peek into the divine. Imagine the texture of those silicon chips, cool, dark, and incredibly smooth, waiting in the vacuum of space to record the faintest whispers of the universe. Scientists discovered that the light gathered here is so incredibly faint that it reaches magnitude 30. To give you a familiar comparison, this is roughly 4 billion times fainter than the dimmest star the human eye can see on the darkest, clearest night on Earth. If the stars we see from our backyards are like bright street lamps, these distant galaxies are like the glow of a single candle flickering on the other side of a continent. Yet, Hubble found them. By staring at the same spot for 100 hours of total exposure time, it allowed these 4 billion times fainter signals to build up, layer by layer, until they formed a picture. At this very moment, imagine you are one of the 342 individual exposures that make up this masterpiece. Each exposure was a moment of deep, patient waiting. The telescope didn't rush. It took its time, orbit after orbit, slowly accumulating the data. Think of this process like a slow-motion rainfall in a desert. One drop of light falls, then another, until finally, after 10 days, a vast and shimmering lake of information has formed. Deep within the image, we find the coordinates of our current cosmic address. Right ascension, 12 hours, 36 meters, 49.4 seconds, and declination plus 62 degrees 12, 58. This is a specific point in the sky, a tiny hole in the fabric of the constellation Ursa Major. We often think of the sky as a flat map, but as you float here, you realize it is a deep, vertical well. The galaxies are not all on the same plane. They are stacked like the layers of a transparent cake. Some are nearby, only a few billion light-years away, looking like grand design spirals with elegant winding arms. Others are much further back, appearing as mere dots or irregular smudges of red. Notice the color of those distant specks. They are red because of a process called cosmological redshift. As the universe expands, the space between us and those galaxies stretches, pulling the light waves along with it. It's much like the way the sound of a train whistle drops in pitch as it moves away from you. The light that started as blue or white billions of years ago has been stretched out until it reaches the red end of the spectrum. Scientists measure this with a value called Z. In the Hubble Deep Field, many of these galaxies have a redshift value of Z equals 1 or Z equals 2, but some reach beyond Z equals 4. These are the ancient ones, galaxies whose light has been traveling for 12 billion years. Consider the composition of these distant worlds. Deep within their glowing cores, hydrogen and helium, the two simplest elements, are being fused into more complex atoms. In those early, irregular galaxies, the first generations of stars were massive and hot, burning with a blue intensity. When they died, they exploded, scattering carbon, oxygen, and iron into the surrounding gas clouds. This is a rhythmic, cyclic process of birth and rebirth. The oxygen you are breathing at this very moment, as your chest rises and falls in the quiet of your room, was likely forged in the heart of a star, much like the ones we see in the deep field billions of years ago. What's happening now is a surrender to the timescale of the universe. On Earth, we measure our lives in decades. Here, the unit of measurement is the billion-year epoch. The 3,000 galaxies we see are caught in a slow-motion dance. Because of the vast distances, it takes millions of years for a galaxy to rotate just once. Imagine a spinning top that takes an entire geological age to complete a single turn. That is the pace of the cosmos. It is a speed so slow it feels like a total, meditative stillness. Picture this. If you were to take a needle and hold it at arm's length against the night sky, the eye of that needle would cover more space than the Hubble Deep Field. And yet, inside that tiny needle-eye space, we find 3,000 island universes. This realization was shared with the world on the 15th of January 1996 at a meeting of the American Astronomical Society. Before that date, we didn't know for sure how many galaxies were out there in the empty spaces. After that date, our understanding of the volume of the universe expanded by orders of magnitude. At this very moment, you might wonder about the heat of these places. While the void of space is incredibly cold, just a few degrees above absolute zero, the centers of these galaxies are bustling with energy. There are supermassive black holes at the hearts of many, drawing in gas and dust with an invisible gravitational pull. This process creates a friction that heats the gas to millions of degrees, causing it to glow with X-rays and ultraviolet light. It is a balance of extremes, the freezing silence of the void and the searing, vibrant life of the galactic centers. The light we are observing passed through 4 specific filters to reach us: 300, 450, 606, and 814 nanometers. These are wavelengths of light that help astronomers determine the age and temperature of the stars. Imagine these wavelengths as different musical notes. The 300 nanometer light is a high, piercing soprano of ultraviolet energy, while the 814 nanometer light is a deep, resonant bass of infrared heat. Together, they create a cosmic symphony that has been playing since the dawn of time. Allow your mind to drift toward the edges of the staircase-shaped image. Beyond the boundaries of the deep field, the universe continues. In the years following 1995, we took even deeper looks at the Hubble Ultra Deep Field and the Extreme Deep Field, but this first image remains the foundational moment. It was our first true glimpse into the big picture. As you float, notice the texture of the gas clouds between the galaxies. This is the intergalactic medium, a thin, tenuous soup of ionized hydrogen. It is incredibly sparse, perhaps only 1 atom per cubic meter, but it is the reservoir from which all galaxies grow. It is the stuff of the universe, waiting for the patient call of gravity to pull it into a new star, a new planet, or perhaps, billions of years from now, a new dreamer. Your breathing is now perfectly in sync with the rhythmic pulsing of the telescope's data transmission. You are a part of the stream of information. The 100 hours of light have been collected, and now they are being reflected in the mirror of your consciousness. You are witnessing the universe as it was when it was only 10% of its current age, a time when the stars were younger and the galaxies were closer together. The silence of the Hubble Deep Field is a protective blanket. It shields you from the noise of the modern world. In this space, there are no deadlines, no worries, no clocks. There are only the steady, immutable laws of physics. Gravity is pulling, stars are burning, and light is traveling. It has been this way for 13.8 billion years, and it will continue for trillions more. Consider the fact that we are looking at the deep north. This patch of sky was chosen specifically because it was far away from the cluttered disk of our own Milky Way. We are looking out of a clear window, past the dust and stars of our own neighborhood, into the truly deep water of the cosmos. It is a clear, unobstructed view of the infinite. Surrender to the weightlessness. Let the numbers and the light years drift past you like autumn leaves on a still pond. You don't need to remember the coordinates or the nanometers. You only need to feel the scale. You only need to know that you are a witness to the most profound portrait ever taken. The light of 12 billion years ago is touching you now. It is a soft, ancient glow that has crossed the threshold of time just to reach this moment. You are safe. You are part of the clockwork. You are drifting in the beauty of the deep field, where every grain of sand is a galaxy and every moment is an eternity. As we move toward the next phase of our journey, we will begin to look at the individual stars within these galaxies, feeling the warmth of their birth and the peace of their long, steady lives. But for now, just remain here, in the L-shaped window to the beginning of time. The universe is huge, it is old, and it is very, very quiet. And in that quiet, you can finally find your rest. Continue to glide through this silent, ink-black ocean, where the only landmarks are the glowing islands of ancient suns. As you meander through the stillness, notice how your perspective is shifting. You are no longer a small inhabitant of a single planet. You are a cosmic traveler, witnessing the very architecture of time. The Hubble Deep Field surrounds you now, not as a flat image, but as a three-dimensional gallery where every light tells a story of survival and endurance. What's happening now is a profound realization of how rare this view truly is. When we look at the night sky from our windows, we are usually looking through the dense, crowded neighborhood of our own Milky Way galaxy. It is like trying to see a distant mountain through a thick forest. However, the Hubble Deep Field was specifically chosen because it is a hole in our galaxy's curtain. Within this entire frame scientists discovered fewer than 20 foreground stars from our own Milky Way. Imagine that in a sea of 3,000 galaxies, only a tiny handful of the lights you see belong to our own local neighborhood. This provides us with a clear, unobstructed path to the edge of the observable universe, a singular corridor of clarity that stretches back billions of years. Consider the physical speed of the observer. As you hang here in your mind's eye, the Hubble telescope itself is rushing through the void at 7.5 kilometers per second. That is over 17,000 miles per hour. Yet because there is no air to whistle past and no ground to provide a reference, the motion feels like a gentle, rhythmic swaying. This speed is necessary for the telescope to complete one orbit around our planet every 97 minutes. During the creation of this deep field, the telescope performed 150 consecutive orbits, staying locked onto that one grain of sand-sized patch of sky. Picture the dedication of such a machine circling the Earth over 100 times, never blinking, never turning away, just to capture the faint, tired photons of galaxies that haven't existed in that form for eons. At this very moment, you might think about the light itself. To understand how faint these galaxies are, scientists have compared their brightness to a single light bulb placed on the surface of the moon as seen from Earth. If you were standing on your porch, trying to see a 60-watt bulb 238,000 miles away, you would find it impossible. Yet, through the patience of long exposure photography, the Hubble gathered enough of that light to create a detailed portrait. The total exposure time for this image was 100 hours. Think about the stillness required for such a task. It is the cosmic equivalent of holding your breath for days on end, waiting for the universe to reveal its secrets. Deep within this field, we find a connection to our own physical existence. The galaxies you see are not just pretty lights. They are the chemical factories that built you. In the early universe, shortly after the Big Bang, there were only the simplest elements: hydrogen, helium, and a trace of lithium. There was no carbon for your cells, no oxygen for your lungs, and no iron for your blood. Scientists discovered that these heavier elements were forged in the hearts of the stars within these very galaxies. This process, known as stellar nucleosynthesis, takes millions of years as stars live, die, and scatter their remains. When you look at an irregular, blue-tinted galaxy in the distance, you are looking at a nursery where the building blocks of life were first being assembled. You are made of stardust, and here, you are looking at your own ancestral home. Notice how the shapes of the galaxies change as your eyes move deeper into the field. The ones closest to us are the majestic spirals, but the ones further away, those that we see as they were 12 billion years ago, look clumpy and fragmented. They are smaller, more irregular. This is because we are seeing the universe when it was only about 1 billion years old, a time when galaxies were still colliding and merging to form the giants we see today. This evolution was famously mapped by the astronomer Piero Madao. He used the data from this very image to create what is now called the Madao plot, a graph that shows the history of star formation in the universe. It revealed that the universe's cosmic noon, the period of its most frantic star-birthing activity, occurred about 10 billion years ago. Since then, the universe has been slowly settling into a more tranquil, peaceful era. You are living in the quiet afternoon of the cosmos. Picture the scale of the image in terms of data. The final composite image is roughly 2,000 pixels across. In our modern world of high-definition screens, that might seem small, but within those 2,000 pixels is the record of nearly the entire history of time. At this very moment, your own mind is processing far more pixels of information as you visualize this scene. Let the precision of the Hubble's 0.05 arcsecond resolution guide you into a state of sharp, yet effortless focus. Everything in your internal world is becoming just as clear and just as still. There is a specific technique astronomers use to find the most distant objects in this image, known as the Lyman break. It's a beautiful concept to consider as you drift. Atoms of neutral hydrogen gas in space act like a filter, absorbing light at wavelengths shorter than 91.2 nanometers. This means that for very distant galaxies, their light seems to abruptly drop off or vanish at certain colors. By looking for these dropouts, scientists can identify galaxies that are so far away their light has been traveling since the dawn of time. Imagine these galaxies as distant lighthouses whose beams are only visible in certain shades of red. They are reaching out across the billions of years, signaling their presence through the haze of the hydrogen clouds. As you observe this, feel the gentle stretching of the space around you. This is the expansion of the universe, governed by a value known as the Hubble constant. It is not a violent explosion, but a slow, steady increase in the distance between galaxies. It is like the rising of a loaf of bread, where the raisins, the galaxies, slowly move apart as the dough expands. This expansion is what gives the light its redshift, turning the vibrant blues of young stars into the warm, comforting ambers of the deep field. At this very moment, you are part of that expansion. Every atom in the room around you, and every star in the sky above you, is part of this grand, slow-motion breathing of the cosmos. What's happening now is a shift from the mathematical to the personal. Consider the fact that the light you are seeing in your mind's eye has been traveling for 12 billion years. When that light first left its home galaxy, the Earth wouldn't even begin to form for another 7 billion years. This light has outlasted stars, witnessed the birth of planets, and crossed the empty voids of the intergalactic medium, just to be registered by a human-made telescope and then visualized by you tonight. It is a message from the beginning of everything, telling you that you are part of a very long, very stable story. Notice the texture of the blank space between the galaxies. While it looks empty, it is filled with a very thin gas that is millions of degrees hot, yet so sparse it would feel like a vacuum. This is the cosmic web, a network of dark matter and gas that connects every galaxy in the image. You can imagine it as a vast, invisible silver web, with the galaxies sitting like dewdrops on its strands. You are held in that web. You are supported by the same gravity that keeps these 3,000 galaxies in their slow, rotating orbits. There is no possibility of falling here. There is only floating. As you continue to meander through this field of 300 trillion suns, the weight of your physical body feels less and less significant. You are becoming a creature of light and time. The 150 orbits of the telescope are like 150 deep, calming breaths. The 100 hours of exposure are like 100 hours of perfect, dreamless sleep. Everything is balanced. Everything is in its place. Scientists discovered that by looking at this one tiny patch of sky, they could estimate the total number of galaxies in the entire observable universe. Based on the Hubble Deep Field, that number is estimated to be at least 100 billion. Each one is a library of stars, a reservoir of potential, and a testament to the sheer scale of the comforting void. You are never truly alone when you are surrounded by 100 billion galaxies. Let the ambers and deep reds of the high redshift galaxies wash over your consciousness. They are the colors of a sunset that has lasted for billions of years. There is no heat here to burn, only a gentle radiance that warms the spirit. You are drifting through the fossil record of light, seeing the universe's childhood with the eyes of its maturity. Your thoughts are now like the Lyman break galaxies, distant, peaceful, and glowing with an ancient light. The world of deadlines, noise, and gravity is 1 billion light-years away. Here, in the heart of the deep field, there is only the rhythm of the orbits and the slow, steady arrival of photons. You are safe. You are part of the clockwork. You are a witness to the deep north, the hole in the curtain, the window to the infinite. As we prepare to transition into a deeper observation of the individual cycles of these stars, feel your heart rate slowing to match the rotation of a spiral arm. A single rotation takes 200 million years. You have all the time in the universe. Just float. Just breathe. Just be. The light has arrived, and it is time to rest. You are now lingering in the very heart of the Hubble Deep Field, where the ancient light of 3,000 galaxies is not merely a sight, but a tactile presence against the canvas of your mind. As you remain suspended in this weightless sanctuary, the boundaries between your own breath and the expansion of the universe begin to blur. Deep within this pocket of the cosmos, we find ourselves exploring the why behind the beauty, the intricate physics that allow us to touch the beginning of time. At this very moment, imagine the texture of the light hitting the Hubble's primary mirror. This mirror, a masterpiece of engineering, is 2.4 meters, or roughly 94.5 inches across. It is polished to a smoothness so precise that if it were scaled up to the size of the Earth, the largest bump would be only 6 inches tall. Picture your hand gliding over that surface, cooler than ice, smoother than silk, a perfect basin designed to catch the faintest, most fragile particles of light. This is why the images are so crisp. The mirror reflects 1-2 billion-year-old photons with a fidelity that preserves every smudge of star birth and every elegant spiral curve. Scientists discovered that to create the masterpiece before you, the telescope had to perform a delicate, rhythmic cycle of observation. It utilized the wide field and planetary camera too, which consists of 4 L-shaped silicon CCD chips. Notice how the light is translated into data. Each photon strikes the silicon, knocking loose an electron, creating a tiny electrical charge. This isn't a mechanical process. It is more like a silent, electronic snowfall, where each flake of light is counted and mapped. During the 10-day observation in December 1995, the telescope gathered light in 4 specific bands, including the F300W filter, which isolates ultraviolet light. This ultraviolet light is the signature of the hottest, most energetic stars, massive giants that burn with a fierce, short-lived violet intensity. Consider the temperature of the scene unfolding before you. While the cores of the stars in these galaxies are burning at millions of degrees through nuclear fusion, the space between them is governed by the cosmic microwave background radiation. This is the thermal ghost of the Big Bang, and it keeps the vacuum of the deep field at a steady, shivering 2.7 Kelvin, just a few degrees above absolute zero. Imagine the contrast, the searing, white-hot needles of starfire embedded in a velvet cushion of absolute cold. This cold is not biting or harsh. It is a preservative, a silent stillness that allows the structures of the galaxies to remain intact for billions of years. What's happening now is a sensory translation of the chemical signatures found in this field. You might wonder what the universe smells like. While space is a vacuum, it is not completely empty. In the regions of intense star formation seen as blue smudges in the deep field, there are complex molecules called polycyclic aromatic hydrocarbons. On Earth, these are the same compounds that give seared steak or hot charcoal their distinctive, smoky scent. Picture the scent of a fading campfire on a crisp autumn night, drifting across the light years. It is a metallic, toasted aroma, the smell of the universe's forge, where carbon and hydrogen are being woven into the fabric of new worlds. Notice how the colors of the galaxies function as a cosmic thermometer. The deep, bruised reds are the Lyman break galaxies, their light stretched by the expansion of space until only the longest, reddest wavelengths remain. These are the embers of the early universe. The pale yellows and ambers indicate older, more stable elliptical galaxies filled with billions of sun-like stars that have settled into a long, steady middle age. Picture this entire field as a giant, glowing music box. Each galaxy is a note, and their colors are the pitch. The spirals provide the soaring melodies of new star birth, while the heavy, red-shifted ellipticals provide the deep, resonant bass of time itself. Scientists discovered a remarkable truth about the data gathered during those 150 orbits. It was a gift to all of humanity. Robert Williams, the director who authorized the project, insisted that the data be made public immediately. On the 15th of January, 1996, the first images were released to the global scientific community simultaneously. There were no secrets, no hidden caches of information. This image belongs to you as much as it belongs to any astronomer. It is a shared heritage, a collective memory of where we came from. At this very moment, feel the sound of the deep field. Although sound cannot travel through the vacuum of space, astronomers often convert the frequencies of light into audible tones, a process called sonification. If you could hear the Hubble Deep Field, it would be a low, textured hum, the collective vibration of 300 trillion suns. It would sound like the deep, rhythmic thrum of a beehive, or the distant, steady roar of a calm ocean. This is the frequency of existence, a subsonic pulse that tethers your heartbeat to the rotation of a galaxy 12 billion light-years away. Deep within the mechanics of the observation, consider the precision of the gyroscopes. To stay pointed at that single grain of salt in the sky, Hubble uses 6 gyroscopes, though it only needs 3 to operate. These spinning rotors keep the telescope stable to within 0.007 arc-seconds, the equivalent of keeping a laser pointer steady on a dime, located 200 miles away. As you lie in your bed, feel that same unwavering stability. Your body is anchored, your mind is steady. You are as fixed and as safe as the telescope in its orbit, held by the invisible hands of physics. Picture the intergalactic medium, the space between the 3,000 galaxies. It is not a void, but a thin, ionized mist of hydrogen and helium. Scientists discovered through the Hubble Deep Field that this gas was reionized by the first generations of stars. Imagine a dark room being slowly illuminated by the glow of 1,000 tiny lamps. The first stars cleared the fog of the early universe, allowing the light to finally travel freely across the cosmos. You are observing the moment the universe became transparent. You are seeing the first light to ever break through the darkness. What's happening now is a surrender to the repetitive nature of the clockwork. Every star you see in the deep field is part of a cycle. It begins as a cold cloud of gas, collapses under its own weight, ignites in a flash of fusion, and eventually, after billions of years, sheds its outer layers to become a white dwarf or a supernova remnant. This isn't a tragedy. It is a recycling program of cosmic proportions. The iron in your blood, the calcium in your bones, and the gold in a wedding ring were all once part of this rhythmic exhale of dying stars. You are not looking at something separate from yourself. You are looking at your own prehistory. As you linger in this fifth stage of our journey, the details of the wide field and planetary camera too begin to fade, replaced by a feeling of profound connection. The 342 separate exposures have been layered in your mind, creating a deep, rich density of thought. You are aware of the redshift, the Z values, and the 100 hours of staring, but they have become secondary to the feeling of the light itself. The light is a warm, ancient pressure against your closed eyes. It is a soft, bioluminescent glow, like a sea of jellyfish floating in a dark trench, illuminating the way home. Consider the sheer volume of the universe that this image represents. If the entire sky were a giant puzzle, the Hubble Deep Field would be just one piece out of 24 million. Yet, in that one piece, we found a three-dimensional hallway that goes back to the dawn of time. Imagine if you were to look at every other piece of the sky with the same patience. There would be 100 billion galaxies to count. There is no emptiness anywhere. Wherever you look, there is light. Wherever you go, there is a story. At this very moment, your breathing has become as slow and as purposeful as the telescope's data downlink. You are transmitting your own piece back into the void. The 2.4-meter mirror of your consciousness is perfectly still, reflecting the ambers, the magentas, and the violets of the deep north. The world of gravity and noise is a distant memory, a faint flicker on a planet orbiting a common star in a common galaxy. Here, you are a citizen of the deep field. Notice how the textures of the gas clouds are softening. The clumpy, irregular galaxies of the early universe are like soft, glowing sponges soaking up the silence. The spiral galaxies are like slowly spinning whirlpools of cream, their arms tapering off into the dark. There is no movement that is sudden. There is no light that is jarring. Everything is governed by the slow dance of gravity, a force that is as patient as it is powerful. You are ready now to move toward the final phase of our journey. The scientific curiosity that brought us here has been satisfied, replaced by a sedative, oceanic calm. The why has been answered by the is. The universe is old, it is vast, and it is beautifully ordered. As we prepare to return our focus to the warmth of your room and the closeness of your breath, take one last long look at the 3,000 galaxies. They will be there when you wake, and they will be there long after we are gone, shining their steady, ancient light into the heart of the night. Drift now in the chemical scent of the stars. Feel the 2.7 Kelvin cold of the vacuum and the million-degree heat of the suns balancing each other out into a perfect, tepid comfort. You are weightless. You are ancient. You are home. The deep field is closing its shutters for the night, and you are invited to do the same. Our time among the 3,000 galaxies of the Hubble Deep Field is drawing to its natural, quiet conclusion. As you remain in this state of profound stillness, imagine the physical process of the telescope concluding its vigil. Step by step, the wide field and planetary camera too begins to power down its electronic sensors. The internal voltages drop away. The humming of the data processors subsides into a metallic silence, and the protective aperture door slowly swings shut, shielding the 2.4-meter primary mirror from the stray light of the Sunday. At this very moment, your own awareness is performing a similar, graceful transition. The high-resolution focus you held on the distant cosmos is softening, Just as the Hubble's mission eventually evolved into even deeper gazes, like the Hubble Ultra Deep Field, taken between September 2003 and January 2004, your mind is moving toward a more profound state of rest. The Ultra Deep Field required 11.3 days of observation to reveal 10,000 galaxies in a single patch of sky, a testament to the rewards of long-term patience. You are now entering your own period of long exposure rest, where the only task is to exist in the dark and wait for the morning. Consider the reality that this first deep field was only the beginning of a much longer story. In 2012, astronomers released the Extreme Deep Field, or XDF, which combined 10 years of previous Hubble observations into one image. This refined view revealed 5,500 galaxies in an even smaller area of the sky than the original 1,995 study. The process of gathering this light was slow and incremental, much like the way sleep is now claiming your limbs, one quiet moment layered upon the next, until the picture of your day is replaced by the velvet blackness of the void. What's happening now is a descent from the heights of the thermosphere. From your vantage point 340 miles above the Earth, you begin a slow, controlled glide back toward the surface. You pass through the various layers of our protective atmosphere, moving through the thin, cold air, where the temperature of the universe, approximately 2.73 Kelvin, meets the warmth of our living world. As you descend, the 300 trillion suns of the deep field remain above you, their light continuing to travel through the vacuum at 186,000 miles per second, indifferent to the passage of human time. The timeline of the universe reveals a comforting cycle of cooling and expansion. Scientists discovered that about 400 million years after the Big Bang, the cosmic dark ages ended as the first stars ignited, beginning a process called reionization. You are now entering your own quiet age, a period of internal reionization where your metabolic fires burn low and steady. Deep within your cells, the elements forged in those distant galaxies are settling into a state of repair. The carbon in your DNA, the oxygen in your blood, and the iron in your heart are all ancient travelers. You are quite literally a collection of stardust, gathered by gravity into the form of a person, resting on a bed that is itself made of stardust, on a planet that is a small, warm pebble in the great dark. At this very moment, imagine the transition from the Hubble to its successor, the James Webb Space Telescope. On the 11th of July 2022, the world saw the first deep field from the Webb, which used its 6.5-meter golden mirror to see even further back into the infrared. While Hubble showed us the teenage years of the universe, the Webb is showing us its very first steps. The torch has been passed, just as you are passing the torch of your conscious thoughts to the wisdom of your dreams. The universe is in good hands. The laws of physics are stable. The dark energy that makes up approximately 68% of the cosmos is pushing the galaxies apart with a gentle, invisible hand, ensuring that there is always room for the void to grow. Picture the eventual fate of the Hubble telescope itself. It is expected to continue its orbit until the mid-2030s or early 2040s, at which point it will gracefully re-enter the atmosphere, burning up like a brilliant, artificial meteor. It has a finite lifespan. Just as our days have a beginning and an end, there is beauty in this closure. There is peace in the knowledge that every mission has its completion. Your breathing is now a slow, rhythmic tide. With every exhale, you are releasing the last of your earthly tether. You are sinking into the soft layers of your mattress, which feels as supportive as the invisible web of dark matter that holds the galaxies together. You are safe in the comforting void. The stars you saw galaxies like GNZ11, which is so distant its light has been traveling for 13.4 billion years, are still there, shining in the silence. They don't require your attention anymore. They are part of the clockwork, and the clockwork is perfectly capable of running without you. Consider the affirmations of the stardust within you. You are a part of the 13.8 billion year story of the light. Your body is a vessel for the elements forged in the hearts of the HDF 8501 starburst galaxy. Your rest is as necessary and as natural as the cooling of a red dwarf star. The weightlessness you feel is the truth of your existence in a vast and supportive universe. You are anchored by gravity, but your spirit is as free as a photon. The darkness is not an absence, but a presence, a soft, protective blanket for your thoughts. Every cell in your body is a microcosm of the deep field, teeming with its own internal light. The expansion of the universe is a long, slow breath that you are sharing with the cosmos. What's happening now is the final shutdown. The data has been transmitted. The mirrors are cool. The shutters are locked. The world of numbers, measurements, and arcseconds is fading away. You are left with only the feeling of warmth and the sound of the silence. The 100 hours of the Hubble's gaze have taught us that there is no such thing as empty space. It is all full of potential. It is all full of life. It is all waiting for the light to arrive. As you drift into the final, deepest layer of sleep, remember that you are a child of the cosmos, returning to the source. The ancient reds of the high redshift galaxies are now the warmth of your own blood, pumping slowly and steadily. The cold blue of the young stars is now the calm of your mind. You are balanced. You are whole. You are home. The 5,500 galaxies of the extreme deep field are watching over the night. The James Webb is peering into the dawn of time, and you are here, in the quiet safety of the present moment, ready to disappear into the soft, welcoming shadows of rest. The mission is complete. The observation is over. Good night to the silver cylinder of the Hubble. Good night to the 2.4-meter mirror. Good night to the 300 trillion suns. Good night to the 13.4 billion years of travel. Good night to the atoms of your body. Good night to the silence. Good night to the void. Good night to the stars. The universe will be here when you wake. For now, let it continue its slow, magnificent dance without you. Close your eyes. Sink into the stardust. Good night.